So let us draw the figure and then we'll discuss. So this question says a particle P is projected with initial velocity 20 meter per second. So this velocity is given to you, and this is 20 meter per second. So let us say V is 20 meter per second. You have at an angle of 75 degrees. So 45 this plus 30, 75 degree to the horizontal from point O at bottom of the plane at 45 degree to the horizontal. So this inclined plane makes an angle 45 degree to the horizontal. Particle hits the plane again at point A. So particle is hitting the plane at A again. Now question says, what is the time of flight? So we have different parts, 3 parts of the question. So first part is we have to find time of flight, and this is easy. So we have to find time of flight. So you see, in this question we will work in terms of coordinate, inclined coordinate. So this is my x-axis and I will consider this is my y-axis. So basically what we will do is we will break the g into 2 components along the incline and perpendicular to the incline. So we have to break the z into 2 components. Are you getting? So we have already done this exercise many times. So if you have a z, this angle is z, and this angle you will find. So this angle is 45, so this angle will also 45. So this angle is 45 degree. So in this direction you will have g cos 45, in this direction you will have g sin 45. So let me write here. So this is my z, this is my incline, this is perpendicular to the incline. So in this direction you have g cos 45. So in this direction you have g cos 45, and in this direction you have g sin 45. Are you getting? Now let us similarly break the velocity. You see, velocity is here. V cos 45, V cos 30 in this direction. So initial velocity is something like this. I can break the velocity into 2 components. So in this direction you will have V cos 30. Let me write 30 degree. So V cos 30, in this direction you will have V sin 30. I think all of you are able to understand this one. This is a pretty easy one. V sin 30. Are you getting? So in this direction you have V cos 30, in this direction you have V sin 30. So let us say to find out the time, so this is the velocity and acceleration diagram you have. So this is my acceleration vectors and this is my velocity vectors. So this is acceleration, in this direction you have, and this is velocity, in this direction you have, in the velocity in this direction you have g v sin 30 degree. Now we can apply equations. So let us write what equation we should write time to find time of flight, and that is very important. If you see along the incline, perpendicular to the incline, the distance traveled is 0. Initially this was on the incline, finally this is also on the incline. So if you see, it has only changed the x coordinate, it has not changed the y coordinate. Y coordinate is here 0, 0, 0, 0. At every point on the incline y coordinate is 0. So I can say distance traveled along the y direction, that is 0. So let us write equation in y direction. So in the y direction total distance traveled is 0. So s is equals to ut. Initial velocity in the y direction is v sin 30. So b ut, and initial acceleration, so basically acceleration is constant, this is negative y side, so minus half g cos 45 into t square. So from here you will get time. So you see you are getting time is equals to 2b sin 30 degree, and this divided by g cos 45 degrees. So that is the time of flight. So if you plug the value, velocity is given to 20 meter per second, sin 30 is 1 by 2, and let us take g is 10, cos 45 1 by root 2. So this value comes out to be 2 root 2. So time of flight is 2 root 2 second. Are you getting? So time of flight is 2 root 2 second. Now B part of the question says what is the range on incline. So B part, I think all of you have copied this one. So to find B part, this says what is the range on the incline. That is important. Range on incline. Now what we will do is, we will write equation in the x direction. So this is my x direction. So we have to find range on incline. So we will write equation in this direction. To find this distance, so let us say we want to find OA. To find OA, I can say S is equals to ut plus half it square in this direction. So I can say S is basically OA, ut, initial velocity in the x direction is b cos 30 into t, S is equals to ut. So you see initial velocity is b cos 30 in this direction. Acceleration is g sin 45, but this is negative x direction. So minus half g sin 45 into t square. And time of flight we have already calculated, that is 2 root 2. So OA will be, velocity is 20, cos 30 is root 3 by 2, and time is 2 root 2, minus half, g is 10, sin 45 1 by root 2, and t square, t is 2 root 2, so this will be 4 into 2 8. So this comes out to be, so this goes, so 20 into root 6, are you getting, so 20 into root 6 minus, and this will we have 2 root 2 into, let us write, so this is 2 root 2 into 20, so this is 20 root 2. Let us check again whether we are getting the same thing or not. So if you take 20 common, this is 20 root 6 minus root 2. So this is the meter, that is the distance covered over the incline. That is important. Now third part of the question says, I think all of you have copied this one. So third part of the question says the greatest height above the plane. That is important. Greatest height. So we have to find greatest height above the plane. Above the plane. So how will you find greatest height above the plane? Can anybody give me some idea? So what we want is, so this is my inclined plane. I want to find what is the maximum height from the incline. So this side I want to find, this, let us say this greatest height is h. I am interested in this side. So what I will use is, when this reaches at this point, this total velocity will be parallel to the incline. Otherwise, if this will have some velocity in the upward direction, it can go again up. But I am saying this is the greatest height, so in this direction there will be no velocity. Are you getting? So at the point of highest, it will have only velocity along the parallel direction. Along the perpendicular direction, it will have a zero velocity. Are you getting? So we will apply that condition. So when greatest height is achieved, velocity perpendicular to the incline will be zero. Velocity perpendicular to incline is 0. So we will apply this condition. Incline is 0. Are you getting? Velocity perpendicular to incline is 0. So if you see along the incline, perpendicular to the incline, if you write v is equals to u plus at, so initial velocity is v sin 30. So v is equals to, final will be 0. Initial is v sin 30. V is equals to u plus at, and acceleration is the negative direction, that is g cos 45. So you see here, so g cos 45, so minus a, that is g cos 45, a into t. Are you getting? So this will give you time. So time is v sin 30 divided by g cos 45. And I want to find h. So now I will apply in the perpendicular direction. So what I want is, I want this height. So I am basically interested to find at this point of time what is h. So now I will write equation in the perpendicular direction. So for this time, so let us say when t reaches to the maximum height, when h, the ball reaches to the maximum height, this is the t. So this is the t for h. Are you getting? So I can write equation in the perpendicular direction, h is equals to ut plus half at square. Initial velocity is v sin 30 ut, and this will be time h minus half, because acceleration is in the negative direction, g cos 45 half a into t square. So this is th. Now you calculate the value of th and you plug the value of th here, you will get the result. So let us calculate the value of th. Velocity is 20, sin 30 is 1 by 2, g is 10, cos 45 1 by root 2. So this is simply root 2. Are you getting? So th is root 2. So if I plug this value, I will get h. V is 20, sin 30 1 by 2, th is root 2 minus half, z is 10, cos 45 1 by root 2, and th square is 2. So what is this value comes out to be? So this 2 goes out. So you can calculate yourself. So 10 root 2 minus 10 by root 2. Are you getting? So that is 5 root 2. So this is 10 root 2 minus 5 root 2. So this is, so let us calculate this value. So this value comes out to be 10 root 2 minus 10 by root 2, that is 5 root 2. So this is simply 5 root 2. Are you getting? So this is the maximum height perpendicular to the plane surface. If somebody asks, so this is the maximum height perpendicular to the plane surface. If somebody wants, what is this point of time, what is the height that is from this incline? So perpendicular height, not from the plane. From this, let us say there is a point on the plane from where this is the maximum height. If you see, this is the vertical height. So if somebody asks what is the vertical height, and that point of time you can say this angle is 45 degrees, so this angle is again 45 degrees. Are you getting? Because this line is perpendicular on this line is perpendicular on this, so this angle is 45 degree. So let me make something like this. Same thing I make again. So you will have this height is h, and if you make a perpendicular from here, this angle is 45 degree. If somebody is interested in this height, so let us say this by, so what will be this height? This is perpendicular, so I can write, this is my inclined plane, so I can write cos 45 degree. So cos 45 degrees, this distance divided by, so h by. Are you getting? So by is nothing but h sec 45. So you will have h is, you see, 5 root 2 sec 45, that is 1 by cos 45. So this is 10 meter. So the maximum height reached perpendicular to the incline. This is not the parallel height this time. So you see this height is not, so this height is a, if I drop a perpendicular from the point to the incline, then in that case this will be the maximum height. You see, this is the maximum height. You cannot have, if you drop a perpendicular from here to here, you will not have a maximum height. This height will be maximum only if it reaches to the maximum height. It reaches to the point when this velocity is perpendicular to this. You getting? So in this question, somebody can ask what is the parallel height to the incline, or somebody can ask perpendicular height if I draw perpendicular from the point from the projectile. So in this question it says find the greatest height above the plane reached by the particle. So greatest height above the plane reached by particle is this. So this is the greatest height reached by the particle above the plane. So if you see greatest height reached by the particle above the plane, if you are here, this is the maximum height. You are here, you will look something in the vertical direction. You are not looking in this direction. If somebody asks greatest height reached above the plane, then you have to see in the vertical direction. What is the vertical height that is maximum? Of course, this will be achieved when this is maximum, when this is at this point. Let's discuss the next problem.